Greenwich Palace, the 29th of January, 1536. In a candlelit chamber, the Queen of England is losing a child. Anne Boleyn, the woman a king tore his country away from Rome to marry, miscarries a baby boy of about 15 weeks. Across the country, on that very same day, her rival, Catherine of Aragon, is being lowered into her grave. The court whispers that the Queen has, in her own words, miscarried her saviour. They're right. Within 4 months, Anne will be accused of treason, condemned by the men who once bowed to her, and beheaded by a swordsman brought specially from France. History blames Henry VIII, his obsession with a male heir, his cruelty, his wandering eye. And all of that is true, but there may have been another killer in that chamber, one no Tudor physician could see, one measured not in ambition or politics, but in a single microscopic protein, drifting on the surface of the Queen's own blood cells. 85% of humans carry that protein, 15% don't. And according to the basic rules of evolution, that 15% shouldn't exist at all. Tonight, we follow the trail from a Tudor deathbed to the mountains of the Basque country, from ancient DNA to modern royal genomes, and we put the internet's wildest theories about this blood on trial. This is the mystery of Rh-negative blood, and the Queen it may have killed. Before we can understand what happened inside Anne Boleyn's body, we need 90 seconds of honest science. Stay with me. Everything that follows depends on it. You know your blood type as a letter, AB, AB, or O. But the plus or minus after it is a separate system entirely, the rhesus factor. It refers to one specific protein, the RhD antigen, sitting on the surface of your red blood cells. If you have the protein, you're Rh positive. If you don't, you're Rh negative. That's the whole difference. No copper-based blood, no glowing veins, just the presence or absence of a single protein, controlled by a single gene on chromosome 1. Rh negative is a recessive trait. To have it, you must inherit a silent, non-functional copy of the gene from both parents, which means it can hide in a family line for generations, invisible, waiting. And its distribution across the world is deeply strange. Globally, only about 6% of humanity is Rh negative. In Europe, it leaps to 15 or 16%, 1 in 6 people. Which means that in the crowded, intermarrying noble families of Tudor England, Rh negative blood was almost certainly present, including, quite possibly, in a young woman raised at Hever Castle in Kent. There's one place on Earth where the frequency climbs higher still, a mountain stronghold where a third of the population carries this blood. We'll travel there soon. But first, back to Anne, because her tragedy shows us, in a single human life, exactly why this blood type is one of evolution's great unsolved puzzles. Anne Boleyn was never supposed to be queen. Born around 1501, the daughter of an ambitious diplomat, she was polished in the most glittering courts of Europe, first in the Netherlands, then 7 years in France, serving Queen Claude. When she returned to England, she was unlike anyone at Henry's court. Sharp, cosmopolitan, magnetic. The king pursued her for years. And in an act that changed world history, Anne refused to become his mistress. So Henry made her his wife, and broke England's 1,000-year bond with Rome to do it. In September 1533, Anne delivered a healthy child, a red-haired daughter who would one day rule as Elizabeth I, perhaps the greatest monarch England ever produced. One healthy baby. Remember that detail. It matters more than anyone in that palace could have known. Because after Elizabeth, something changed. The following summer, a pregnancy ended in loss. Evidence suggests possibly another failed pregnancy after that. The records are frustratingly thin, as Tudor courts hid royal miscarriages like state secrets. And then came January 1536, the son lost at 15 weeks. 3 pregnancies after Elizabeth by most reconstructions, not one living child. Now watch what this pattern looks like through the eyes of a modern haematologist. Imagine Anne was Rh negative, statistically plausible for an English noblewoman, and Henry was Rh positive, meaning their babies likely were too. During Elizabeth's birth, a small amount of the baby's Rh positive blood would have crossed into Anne's bloodstream. Her immune system, meeting the Rhd protein for the very first time, did what immune systems do with anything foreign. It built weapons. Elizabeth was safe. First pregnancies usually are. But Anne's body now remembered. In every Rh positive pregnancy that followed, her antibodies could cross the placenta and attack the baby's red blood cells, destroying them faster than the child could make new ones. Anemia, fetal death, miscarriage after miscarriage, each one more dangerous to the dynasty than the last. The condition is called hemolytic disease of the fetus and newborn. Today, we prevent it with a simple injection developed in the 1960s. In Tudor England, there was no injection. There was only a king growing colder, a court sharpening its knives, and a queen whose survival depended on producing a son her own blood may have made impossible. On the 19th of May, 1536, Anne Boleyn knelt in the straw of Tower Green. The French swordsman took her head in a single stroke. She was condemned for adultery and treason on evidence historians overwhelmingly consider fabricated. But the reason Henry wanted her gone was simpler: no son. If the Rh theory is right, a queen was executed for a protein. But is it right? Can we actually test it? That question leads us to a Victorian chapel, a locked royal vault, and the strange afterlife of Anne Boleyn's DNA. Here's the uncomfortable truth up front. No one has ever sequenced Anne Boleyn's DNA. Not because we don't know where she is, but because of where she is. After the execution, Anne's body was placed in an old arrow chest and buried beneath the chapel of St. Peter ad Vincula, inside the Tower of London. There she lay until the 1870s, when Victorian restorers lifted the chapel floor and found bones they attributed to her. A slender woman in her 30s, they reported. But Victorian identification was educated guesswork, and the remains of several executed nobles lay tangled in the same ground. Even which bones are Anne's is uncertain. The remains were reburied beneath the altar, where they rest today, and repeated proposals to test them have been declined. The chapel is a royal peculiar, under the Crown's direct protection. No exhumation, no sample, no verdict. So the Rh theory of Anne's miscarriages remains exactly that, a theory. Plausible, consistent with her obstetric pattern, taken seriously enough that historians and physicians have debated it for decades, but unprovable, for now. And yet, Boleyn blood didn't die on Tower Green. It's flowing through some very famous veins right now. Anne's direct line ended with Elizabeth, the Virgin Queen, who left no children. But Anne had a sister, Mary Boleyn, and Mary's descendants multiplied through the English aristocracy for 5 centuries. Trace those family trees forward, and you find Winston Churchill, Princess Diana, and through Mary's daughter Catherine Carey, the late Queen Elizabeth II herself, meaning the current royal family carries Boleyn ancestry. The dynasty that destroyed Anne ultimately reabsorbed her bloodline through the sister history nearly forgot. There's even a theoretical path to an answer. Anne and Mary shared a mother, which means they shared mitochondrial DNA, the genetic signature passed unbroken from mother to daughter. If the Tower remains were ever tested against a documented female line descendant of that Howard maternal line, we could confirm which bones are Anne's, and potentially read her blood group genes directly from 500-year-old DNA. The science exists today, only permission is missing. Until that day, Anne's blood keeps it secret. But her pattern, one healthy child, then cascading losses, is not unique to her. It has echoed through thousands of years of human motherhood. And that raises the question at the heart of this entire mystery. If this blood type killed royal children and ordinary children alike, why does it still exist? Evolution is ruthless about reproductive math. A gene variant that costs mothers their children should shrink generation after generation until it vanishes. Rh-negative blood should be a rare footnote in the human genome. Instead, in Europe, it reached 1 in 6 people, and in one place, it reached 1 in 3. The Western Pyrenees, on the border of Spain and France. The Basque country, Euskal. By nearly every measure a geneticist cares about, the Basques are an anomaly. Their language, Euskara, is a linguistic orphan, related to no other language on the planet, a survivor from before the Indo-European tongues swept across the continent. And in the mid-20th century, researchers drawing blood in Basque valleys found Rh-negative frequencies between 25 and 35%, the highest ever recorded on Earth. An isolated people, an impossible language, the world's densest concentration of the blood that shouldn't exist. You can imagine the theories. But modern genome sequencing tells a grounded and more interesting story. Basques are deeply European, descendants of the same Ice Age hunter-gatherers and early farmers as their neighbours. What makes them different is what didn't happen. While the rest of Iberia absorbed wave after wave of newcomers, steppe herders, Romans, Visigoths, Moors, the Basques, shielded by mountains and language, mixed far less. Their valleys became a genetic time capsule. And in a time capsule, chance gets amplified. If the early Basque population happened to carry extra copies of the Rh-negative variant, isolation would lock it in, and inbreeding within the community would push it higher, a process called genetic drift. The Basques didn't receive this blood from outside humanity. They preserved it, like an insect in amber, from Europe's deep past. So we know where the variant survived best. We still don't know why selection tolerated it anywhere. And before we get to science's real suspects, we need to deal with the theories that have racked up millions of views. Because according to large parts of the internet, we've had the answer all along. It just isn't from this planet. Theory 1. The alien hybrid. Rh-negative blood, the claim goes, can't be traced to an earthly origin, so it was introduced by extraterrestrials. The Anunnaki, the Nephilim of Genesis, take your pick. The DNA verdict. The Rh-negative variant isn't an addition to the human genome, it's a deletion. In most Rh-negative people, the RhD gene is simply missing, removed by a well-understood copying error between two nearly identical neighbouring genes. Geneticists can point to the exact molecular scar. If aliens wrote this, they did it by deleting a paragraph from a book humanity already owned. Case dismissed. Theory 2. The Neanderthal inheritance. More reasonable. We do carry Neanderthal DNA. But sequenced Neanderthal genomes came back Rh positive, some carrying a rare RhD variant, but positive nonetheless. The deletion appears to be our own invention. Dismissed. Theory 3. Royal blood. The claim that Europe's monarchs are disproportionately Rh-negative, marking a sacred bloodline. Ironically, the one royal case with real substance is the one we've spent this video on, and Anne's story is about this blood destroying a royal line, not anointing one. Beyond that, no verified data. Royal blood types are private, and the claim circulates source-free from website to website. Dismissed. Here's why these myths thrive. For decades, science couldn't fully explain this blood. Mystery is a vacuum, and vacuums get filled. But dismissing the myths doesn't close the case, because the genuine scientific mystery is still open. And in 2010, it took a twist that leads straight back to the Tudor court. Why did evolution keep a variant that cost mothers their children? Science has three serious suspects. Suspect 1. Pure chance. Genetic drift and founder effects in small ancient populations. The same force we saw in the Basque valleys. Sometimes a costly variant simply gets lucky, spreading too widely to be filtered out quickly. Suspect 2. A hidden advantage. Genetics has a famous pattern called heterozygote advantage. Carrying one copy of a risky variant protects against something else, the way sickle cell trait shields against malaria. Some researchers suspect Rh-negative carriers gained resistance to a pathogen stalking ancient Europe, a brutal evolutionary trade that balanced the lost pregnancies. Suspect 3 is the strangest, Toxoplasma gondii, a parasite spread by cats that silently infects perhaps a third of humanity. Czech researcher Jaroslav Fleger published studies suggesting infected Rh-negative people showed slower reaction times, while Rh-positive carriers seemed partially shielded. If the Rhd protein does something protective we never appreciated, the whole cost-benefit ledger of this blood changes. But honesty matters. Fleger's findings are contested, replication is mixed, and remarkably, the true biological function of the Rhd protein is still not fully understood. And Anne? In 2010, researchers Katrina Banks-Whitley and Kyra Kramer re-examined the Tudor tragedy and flipped it. Maybe the problem was never Anne's blood, but Henry's. They proposed the king carried the rare Kell antigen, a different blood group protein that triggers the same immune warfare. First baby survives, later babies die. It elegantly explains not just Anne's losses, but Catherine of Aragon's 6 doomed pregnancies before her. 2 wives, 1 pattern, 1 shared factor, the king himself. And the theory carries a dark final act, a related condition called MacLeod syndrome, which can emerge in Kell-positive men around age 40, bringing physical decline and psychological changes, paranoia, instability, rage. The exact transformation history records in Henry, right as he turned from golden Renaissance prince into the tyrant who filled Tower Green with blood. If Whitley and Kramer are right, the killer wasn't in Anne's veins at all. It was in Henry's, and it may have written itself into his mind. So where does the trail end? Rh-negative blood is not alien, not Atlantean, not Neanderthal, not the mark of sacred kings. The DNA record is clear. What remains is stranger. A deletion in a single gene, function still debated, that should have been purged by natural selection and instead conquered a sixth of Europe. A mountain people who preserved it like amber, speaking words no conqueror could translate. And a queen who may have knelt on Tower Green because of an immune reaction no one would understand for another 400 years. Anne Boleyn was executed on fabricated charges, condemned in truth for failing to deliver a son. Whether the saboteur was her blood or Henry's, we cannot yet say. Her bones lie sealed beneath the Tower Chapel, holding the answer in fragments of 5-century-old DNA that no one is permitted to read. But her legacy escaped the Tower twice, through her daughter Elizabeth, who gave England a golden age, and through her sister's bloodline, which quietly flowed forward into Churchill, Diana, and the royal family reigning today. The myths promised that Rh-negative people were special. The truth is better. This blood is a message, a trace of vanished pathogens, forgotten migrations, and evolutionary battles fought in the bodies of women whose names, unlike Anne's, we will never know. So now I have to ask, what's your blood type? Are you part of the 85% or the 15%? Drop it in the comments along with where your family comes from. Let's map this mystery together. And if you're Rh negative with Basque roots, I definitely want to hear from you. The Basques are getting their own full investigation soon. An entire people hiding an entire chapter of Europe's lost past. Subscribe and ring the bell so you don't miss it. Until then, the past is closer than you think. Sometimes it's inside your veins.